All right, guys, here's how I want you to think about attacking a problem that looks like this. If I have a problem where it says find the sine of 2 pi over 3. Now, you might be thinking to yourself, how do I solve something like this? What is the algorithm that I should be starting in my head, right? Whenever you see a problem like this, I want you to draw three things. The three things are your common trig ratio table. Okay, so you would set this up. You would write sine theta, cosine theta, tan theta. And the rows would be pi over 6. I mean the column, sorry. Pi over 4 and pi over 3. Okay. And you would fill this out using the tricks that we talked about in previous videos, right? So you would have 1/2, 2 over 2, 3 over 2, square root the top. Then you're working backwards in this one, 3, 2, 1, square root the top, divide by 2, divide by 2, divide by 2. And then for the bottom here, you would just be dividing the sine over cosine to get the tangent, right? So you would have 1/2 divided by rad 3 over 2, 1/2 times 2 over rad 3, cancel, 1 over rad 3, 1 over rad 3, rad 2 over 2 divided by rad 2 over 2 is 1, rad 3 over 2 divided by 1/2, rad 3 over 2 times 2 over 1, rad 3, okay? So this is how quickly and automatically you should be regurgitating this table every time you see a question that's asking you for the exact value of a trig ratio. The second thing that you need to draw, right, so this is the first thing you need to draw. The second thing that you need to draw is your little sign chart, and that tells you anteaters slurp tiny creatures. That tells you what trig ratios are positive in that respective quadrant. So in here we have all positive, here we have sine is positive, here we have tangent is positive, and here we have cosine is positive. The third thing that you need to draw is, and this is really two things, but a sine curve. Okay, so we have it going from -1 to 1, zeros in the middle. A sine curve starts at the origin, pi over 2, pi, 3 pi over 2, 2 pi. And it completes one cycle at the end of 2 pi. Its maximum is going to be at pi over 2. Its minimum is going to be at 3 pi over 2. It passes through at pi. Okay. And then you would draw cosine. Okay. 1, -1, zeros in the middle. Okay. Same thing, we count by pi over 2, pi, 3 pi over 2, 2 pi. Okay. Cosine starts up here, completes its cycle at 2 pi. All right. Its minimum is going to occur at pi. Ooh, this is not really very symmetric, but it passes through at pi over 2, 3 pi over 2. Okay. This is a really bad looking cosine curve, but you get the idea. Okay. So when you are solving a problem where it says find the exact value of a trig ratio, these are the three things that you're going to draw. And you have to get pretty fast at drawing them. Okay. There are two things that you need to decide once you have set these three pieces of information up. The two things that you need to get in order to solve or in order to evaluate a trig ratio are, number one, you need to decide the sign. And that's S-I-G-N, not S-I-N-E, right? So I'm going to write in here positive or negative. And then number two, you need to decide the value. And the value is going to come right from this table here. Okay, this is how you decide the value. Okay. So here's how I decide the sign, right? Think about 2 pi over 3 as a rotation, right? I want to see what quadrant a rotation angle of 2 pi over 3 will terminate in. And in order to do that, I have to sketch it, okay? I always want to see you guys sketching these angles because that's what helps you think about it. So I can figure that out by looking at my unit circle and thinking about it in terms of counting in increments of pi over 3, right? So I know that the unit circle begins at 0, and this is pi. However, I'm going to count in terms of pi over 3. So that means I'm going to rewrite this pi as 3 pi over 3. It's still equivalent to pi, but now I'm thinking smart, right? I'm counting smart. So pi over 3 would occur in quadrant 1. So 2 pi over 3 must occur in quadrant 2. Do you see how I'm counting in terms of pi over 3? Now I know the sign of all these things in each respective quadrant. Anteaters, slurp, tiny creatures. In quadrant 2, sign is positive. So I've got my sign. I've decided my sign. Heck yeah. Okay. Check. It's positive. And let's see. I need to decide the value now. Okay. So here's how I decide the value. We know the sign of pi over 3 is rad 3 over 2. Do we know that? We do know that because it says it right here on the chart, right? We know that the value is going to be rad 3 over 2. But let me tell you why the sign of 2 pi over 3 is also rad 3 over 2. Huh? Why? Because if you look at the graph of the sine curve and its periodic nature, think about counting in increments of pi over 3 again, right? We call this its periodicity or whatever. Think about counting in terms of pi, in increments of pi over 3 again. If I put pi over 3 on the graph, right, it's going to be somewhere around here. I hit pi over 3 before I get to pi over 2, right? And up on the graph, it would look like it would be somewhere over here. So if I count pi over 3, then I count to 2 pi over 3. I'm moving along the x-axis counting, right? I should get to 2 pi over 3 somewhere over here. Definitely before I get to 3 pi over 3, right? Let's rewrite pi as 3 pi over 3. Okay, and if you'll notice, I am getting to 2 pi over 3 at the exact same y value height that I got at pi over 3. This is called the periodic nature of a trig function, right? I keep hitting those same values as I travel through the curve, as I travel through my rotations, right? The symmetry of the sine curve is going to allow me to extrapolate that the sine of 2 pi over 3 is the same as the sine of pi over 3, and they are both positive. Why are they both positive? Because they're above the x-axis. So I've got a positive rad 3 over 2 as my answer. So I've showed you that we decide the sign using this guy, anteater, slurp, tiny creatures, and we decide the value using the common trig ratios table highlighted in purple. If I asked you, hey, what is the sign of 4 pi over 3? So let's say I said, what is the sign of, find the sign of 4 pi over 3? What I'm doing is I'm still counting in increments of pi over 3. I'm just going past pi now. Think about it on my little sine curve over here. I'm going past pi now. So if you envision it, 4 pi over 3 would be out here now. Probably like here. I'm going to use a different color because my sine curve is getting a little crazy looking. Okay. It would be like out here now, right? So I've got 4 pi over 3. And the corresponding value down on the graph would be here. And that would be a negative rad 3 over 2. Okay. And if you kept counting, right? If you kept counting in terms of in increments of pi over 3, I would get to 5 pi over 3. And that would be right over here, assuming my graph was symmetric. It should be. And that's why sine is going to be negative in quadrants 3 and 4 because on the other side of the sine curve, the y values are negative. So to find the sine of 4 pi over 3, I would see that it's still rad 3 over 2. It's just negative now. Typically, when we answer a question like this or a question like this, we don't focus on the periodic nature of the curve or like the cycleness of the graph like we did when we were like talking about it up here. But rather just on the table, you would choose the appropriate trig ratio and look at the denominators, right? These angles up here are called reference angles. These are called reference angles. Reference angles. And you'll notice that whenever they ask you to find the exact value of a common trig ratio, the denominator is always going to be a 3, a 4, or a 6 because you need to use these reference angles up top to get the value, to get the appropriate value on the chart. Okay, so let's try another one. We are not like focusing on the graph like we did with this blue part here, but rather I want you to think about it by like solving by the appropriate trig ratio and the quadrant the angle terminates in, right? Okay, so let's try another one here. We have example 3. Find the cosine of 11 pi over 6. Okay, so first we need to decide the sine, right? We have to find the quadrant that the angle terminates in, right? So think about your coordinate plane. This is 0. This is pi. We are now counting in increments of 6. Okay, so I'm going to rewrite this as 6 pi over 6. When I'm counting, this one is going to be 1 pi over 6 in quadrant 1. As I get to pi over 2, right? This is pi over 2. That's going to be in terms of pi over 6's. What's that going to be? Let's see. This is going to be 3 pi over 6, right? So then as I get over here, 4 pi over 6, probably this is going to be 5 pi over 6, right? And then I get to 6 pi over 6, and then 7 pi over 6. And then 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. 11 pi over 6 is going to end up over here, okay? And I know that it's not going to be at 2 pi yet because 2 pi written in terms of pi over 6 would be 12 pi over 6. So I know that 11 pi over 6 has got to end in the fourth quadrant. So in the fourth quadrant, anteaters slurp tiny creatures. Cosine is positive. Okay, so I've got my sine. The sine is going to be positive. And now I need to decide the value. So this denominator, it told me, hey, can you count in increments of pi over 6? But it's also telling me, hey, can you look at the common trig ratios table highlighted in purple and use the pi over 6 reference angle on the chart as your little column to look in, okay? So I'm using the table to get the value. I'm going to use pi over 6 as my reference angle, and we're looking for the cosine. So I'm going to go down to the third row. And I'm in the first column. So I am looking at rad 3 over 2 again. So this is going to be a positive rad 3 over 2. Positive rad 3 over 2. Okay. The end.